All right, let's look at some calculations. All right, suppose at Chief College the proportion of all students that like her show is 0.82. 82% of the students at her college like her show. Good for her. If she takes a sample of 31 students, does the central limit theorem apply in this case? All right, we remember last time we just needed more than 30. So let's check and see if that works here. Right. So our two conditions, right, is our sample size times our proportion greater than or equal to 10. So our sample size is 31, our proportion is 0.82, and we get 25.42. And that is indeed greater than 10. So yes, it looks like from the one side we're in good shape. But remember, we need to try both sides, right? This is the yes side. Now let's check the no's. Okay. So is our sample size times 1 minus p, the proportion of no's, also greater than 10? Okay. 31 times 1 minus 0.82, right, is the same thing as 31 times 0.18, right? 18% don't like the show. And I get 5.58, right? And that's going to be a problem for us, right? This is less than 10. So no, the central limit theorem doesn't apply, and we can't use any of the tools from the standard normal distribution that we've developed. We don't have enough data points on the no side, right? We can't expect enough data points on the no side to get reliable results. So we need a larger sample. Let's check the next one. All right, so in this case, all right, the proportion is still 0.82. In this case, we're going to look at a sample of 56 students. Does the central limit theorem apply? So let's check the yes side and check the no side. The yes side is NP greater than or equal to 10. Well, 56 times 0.82 is 45.92. We would expect this to be good, right? Because 31, we had large enough of a value. We increased our sample size, so this is still going to be good. We can expect that. Yep. So yes. Now the other side is where we had the problem, right? The lower proportion one is always going to be kind of our real main issue. All right, 56 times 1 minus 0.82 is 56 times 0.18, which is 10.08. And that qualifies. We're greater than 10, so we're greater than or equal to 10. So yeah, the central limit theorem applies, and we can use the standard normal distribution to do our calculations of our probabilities. So the thing we need next is the mean and the standard deviation. All right, so proportion is 0.82. We have a sample size of 56. We know that's big enough. Anything larger is also going to work here. So what's our mean and our standard deviation of our sampling distribution, the place where our p-hats are going to come from? So what's the mean of our sampling distribution, right? The big hump in our standard normal distribution. Well, that's just p in this case. It's 0.82, right? The means of our data and the means of our sampling distributions are the same, and that's really nice. Now, the next thing we need is our standard deviation, and that tells us how wide that peak in the middle has to be. All right. Our standard deviation of our sampling distribution is the square root of 0.82 times 1 minus 0.82, that's our 0.18, divided by 56, and that is, to 4 decimals, it's 0.0513, right? Our standard distribution comes out to be about a little more than 5%, right? So we'll use these to do our calculations on our standard distribution model on the next step. Okay, so we have our sample proportion of 0.82. We have our sample size of 56. We know that works. We have our mean of our sampling distribution and our standard deviation of our sampling distribution. Okay, so what is the probability that she takes a sample of size 56 and it has a sample proportion of 75% or less, right? So this is going to be 0.75 or smaller, right? P hat is less than 0.75. Okay. Right. If we have a TI-84 calculator handy, we do the normal CDF. We're looking for the fewer sides. This is -1 E99, -1 times 10 to the 99th. We're going up to our 75%, that's 0.75, our mean, and our standard deviation. And this calculation gives us a probability of 0.0862. Right? So there's a little more than 8.5% chance that our sample will be 75% or less. Okay. All the other similar probabilities can be calculated similarly, right? If we want middle, right, say between 65% and 80%, oops, all right, we just substitute that in for the low, that in for the high. The mean and the standard deviation aren't going to change. Other interesting things that we could calculate, right? What's the range of the middle 50%? Let's remember that the middle 50%, this is going to be our quartiles, Q1 to Q3. The middle 50% is in there. Okay, so we calculate this by doing an inverse norm. We want to find the proportions at the Q1 value and the Q3 value. So the 25th percentile, do the inverse norm of 0.25 of our mean and our standard deviation, and we get 0.7854, right? And that's going to be our Q1 for this value, right? So anything less than 0.7854, 78.54%, that's going to be in the bottom quarter of the data. In between this value and what we're going to get for Q3, that's going to be our center half. Right, and Q3 is at the 75th percentile, so 0.75 of the data. There's our mean. There's our standard deviation. Again, this is an inverse norm. We're looking for these proportion values, these sample proportion. And we get 0.8546, right? And that's Q3. Right? So 50% of the data is going to be between 78.54% and 85.46%, centered around our 82. Anything higher than that is in the upper quarter of the data.